All right, so let's see what we got so far. We have our dungeon populating. If I remember correctly, we added 3 monsters somewhere. I think right now I can jump into the dungeon and walk around a little bit, and I see them standing there. Is that right? Is that the current? They're not doing any movement or anything, but I see them standing there. But they're spitting out. I'd like to do this. I'd like to do this. Okay, there we go. All right, so right off the bat, we want to probably have them be a little less chatty for the moment. All right, so here's our run method inside of our worker bee. This is where we're printing some stuff out. So if we just comment that out for a second, we come back in here and run it. Now it should be standalone. All right, we see Mr. Gonzalez lurking around there. If I head to the north, nobody there. Head back to the south, still see Mr. Gonzalez. Okay, so now when we activate our worker bees, tell them to start going. Well, actually, they're already starting to go. They're just not actually trying to change rooms. When, for example, Mr. Gonzalez decides he wants to try to go to the north, assuming that is a legal exit. So that's probably one thing we need to do if we want to break this into small pieces. A worker bee is going to make a monster, which lives inside of a worker bee, makes the decision that it might want to go in a certain direction. The first thing we probably need to do is ask that room, do you have an exit in that direction? Seem reasonable enough? All right, we could break it into other pieces. You could just say, well, I'm going to try to go to the north end, and it might work, it might not. But we could also wrap it inside of a thing and break it into smaller pieces. And we might also be interested at some future point in time to be able to ask the question of a room, do you have an exit to the north, to the east?
I didn't get that.
Why? You might have a need to ask a room if they have an exit in a certain direction for some other purpose. So let's go to room here. And let's just teach rooms how to return true if they have an exit in a certain direction and false otherwise. Okay, so we're going to create, I can't edit. Oh, it's still running. All right, so public Boolean. So this guy's going to return a true if there is an exit in that direction, false if there's not. So we'll call this guy has exit, and we'll take in a direction as a parameter. All right, so all we're doing is adding the ability to a room where we can say, do you have an exit to the north? And it'll spin through all of its exits, finding out if any of them have a direction to the north. If it finds one, return true. If it doesn't, return false. Make sense? All right, so we're going to get a direction here. We're going to go ahead and go through all of our exits for I is 0. I is less than this dot number of exits. I plus plus. Okay, so for each of those exits, here's our exits. Do we have the ability to ask an exit for its direction? We do. So for each of those exits, we're going to say, what is your direction? And does that direction equal the direction we're looking for? All right. So we're going to say if this dot, the exits at bucket I dot get direction, if that guy, that's the string representation of the direction that this exit heads, if that guy dot equals, we could do dot equals ignore case if we wanted to, but we'll just say dot equals the direction that was passed in. If that's true, we'll return true. Make the function immediately end. We found a match. You asked if there was an exit to the north. I found an exit to the north. Return true. If I go through and I've checked every single one of my exits and I do not find an exit in a certain direction, I'll return false. All right. So we've taught rooms how to report to us whether or not they have an exit in a certain direction when asked. All right. So back inside of worker bee, the worker bee has picked a direction in which they would like to potentially go. some random direction, north, south, east, west. Now they need to ask the room that they're in. Does my room have an exit in that direction? All right. What is the room that the monster is currently in? Well, all inhabitants have a current room. All inhabitants have the ability to give us the current room. We can then ask that room if it has an exit, right? We just taught it that. So we're going to say if this dot the monster, that is the monster associated with this particular worker bee, if that guy dot get, I call it get current room. Yeah, get current room. Steal that. If that guy dot get current room dot has exit in the direction that we randomly generated, pick a direction, ask the room we're currently in, or ask the room the monster associated with this worker bee is currently in, whether it has an exit in that direction. If it does, we're going to take the exit. So we'll put a little statement here, system.out.println. Does a monster have the ability to give us its name? Get name, yep. So we'll go ahead and say this dot the monster dot get name concatenated with leaves to the direction. Now we haven't actually made him leave yet, but we'll just give a little commentary that he can leave. So we focus on Mr. Gonzalez in the first room, right? He's only going to ever actually leave when he rolls the dice and finds a north, right? Because that's the only direction you can leave when you leave that room. Okay. So we should be able to sit there and stare at Mr. Gonzalez for anywhere between a third of a second and probably 10, 15 seconds or so before he finally rolls a north, which would fire this particular guy. All right. So understand the question we're asking here. So we pick our random direction, which we were already doing. Now we're asking, does the room that the monster that's associated with this worker bee, does his current room have an exit in that direction? If it does, we'll say something like, we've left to the north, even though we're not actually leaving to the north yet. All right, see this guy go. We're mostly interested in the Mr. Gonzalez one, but Mr. Gonzalez leaves to the north. Oh, now all the other guys are going different directions too. Okay. But Mr. Gonzalez was the one that we knew how many exits he had. He only had one, so it was a little bit slower to get them going. All right. So now we've given some commentary that he leaves to a certain direction. Whether or not that's a good idea or not, we can decide, because then it gets things a little bit, you get a lot of verbose stuff coming to the screen rather than seeing the room you're in with the current exits, but life goes on. All right. So, but now we need to make him actually leave the room. Well, inside a room, we have the ability for a player to take an exit. We also have the ability to remove a player from a room, right? So when a player takes an exit, it's going to go through that exit, but it's also going to get removed from the current room. So we'd like to have a way for a player to take an exit, or a monster to take an exit. So why don't we go ahead and we'll just copy the take exit for player code. as our starting point, except this time, this guy is going to be a monster. Okay. Now, it's important to note here that we have two functions, one called take exit that takes a monster in a direction, the other one called take exit that takes a player and a direction. Okay. Now, these guys, even though they have the same name, they have a different a number and or type of parameters. One takes a monster, one takes a player. So that is how Java will be able to differentiate between these two, depending on which one we call. If we call the function called take exit on room and we pass it a monster and a direction, it'll call the version of take exit that takes a monster and a direction. Make sense? We could have written this function once and have it take an inhabitant in a direction, then ask what kind of inhabitant are you, and then have it either operate off of the players array or the monsters array. But we're going to have two separate things here. So even though these functions look almost identical, one operates on monsters and strings, the other one operates on players and strings. Okay, so take exit for a monster. We have our exit to take. We spin through. We look to see, do we have that exit? Now, from our perspective, since we know we just built this ability into Room to ask, do you have this exit? We could update this to utilize that, or we can just say, hey, you know what? We might want to ask Rooms that for some other reason, whether or not they have an exit. That's a ability that could be beneficial. We already wrote the code here that spins through and tries to grab the exit that we want. All right. Then we're asking the question, did we actually find an exit? Is there really a thing to take? All right. If there is not, we'll print out exit not found. We know this won't happen for our monsters, right? Because our monsters have already pre-checked whether or not the room they're in has an exit, but we can leave the logic in there. It's not hurting anybody. A little bit less efficient, but just in case somebody changes this and doesn't pre-ask the room, is there an exit before I try to run into the wall? We're going to go through and effectively look at the exit. All right, so if the exit was found, what do we want to do? We want to remove this monster from the room. It's going to be a very similar function to remove player from room, except we're going to be modifying the monsters array instead of the players array. All right, and then we want to, in this case, we are adding a player to our exit, so we're going to have to update this guy. So what I'm going to go ahead and do is I'm going to say add monster. Okay. Now, the reason I went ahead and made these changes now, even though I have not written those functions, is in case I get interrupted or I forget and I'm done for the day or whatever. If I run this right now, I'm going to have some errors, right? Because I'm calling some functions that don't exist yet. Right, so sometimes you can kind of leave yourself reminders in your code of what you haven't written. Whereas if I had left it as remove player from room, that's technically not an error. It's not what I want to do, but it's not an error. Actually, a monster is not a player, so it would give me an error for that. Yeah. If it was inhabitant, it wouldn't. All right, but let's go ahead and fix these things. So we need to write remove monster from room. We already have a remove player from room. So here's our remove player. Let's update this guy for remove monster. All right. I like to rename the variable. All right. So we're going to go through current number of monsters in the room. If the monster we're currently looking at is equal to the monster that we're looking for, that is to say, do they share the same memory address? When we use the double equal sign, we're comparing the primitive type values of these objects. We're not saying, do these monsters have the same name? We're saying, is this the same monster? Same memory address. Okay. If it is, good. The monsters, that guy. Okay. Assuming we did find the guy we want to remove, we're going to go ahead and go through our local monsters array, current number of monsters. And we're going to shift everything down, right? The monsters at bucket J minus 1 is equal to the monsters at bucket J. So remember, we found the dude. So we're basically going to delete him by overwriting him, right? By taking everything from that point forward and shifting everything back, overwriting this stuff. So after we are done with this particular loop through here, we have effectively removed this monster from the room, right? We've effectively told our monsters array to forget about that guy. You've been overwritten. We're no longer keeping track of you. Make sense? All right. So rather than actually remove him, we just overwrote him in the book of monsters. Okay. So that's what remove monster from room will do. Go through all of our monsters. Once we find the monster we're interested in, go through that same array of monsters, overwrite the guy we found, and reduce the number of monsters that are in the room by 1. All right. So now back up here for remove monster. Take exit for monster. This is we'll remove the monster from the room. So now he's gone. And then we're going to ask the exit to add a monster to itself. So here's exit. Right now we have add player. So we're going to go ahead and write add monster. It's monster M. Go ahead.
Player, you can change it, you defined it twice. Would it just quietly use the second?
It'll scream at you. It'll say this is a redefinition of something that already exists. Effectively the same errors you get when you try to create a variable that already exists in the current scope. All right, so we will add a monster. Which monster? Monster M. Where are we adding it? We're adding it to a destination room. What destination room? The one associated with this exit. Okay. Again, try to, I know there's kind of a lot of moving parts in here, but understand that we're kind of letting it grow organically. I keep verbally saying things like, what do we want to do if I'm a monster? Well, first I need to get myself out of the room that I'm currently in. How do we get that information? So you really want to take these little tiny baby steps. If you go back to 200 and you think about when we first started talking about algorithms, and we also first started talking about what makes programming difficult, it's really this stuff, being able to break problems down into these little tiny steps. Sometimes you might say, well, I'll never even ask that. Like, for instance, we could have, if we backtracked a little bit today, we could have said, I never actually have to ask a room whether an exit exists because I sort of kind of have that logic already built into my take exit. But we went ahead and left it in there because you know what? At some point we might want to query the room we're in to find out if there's an exit in a certain direction before we sprint at that wall. But I'd like to let the code kind of grow organically and don't try to solve all the world's problems. But really, this is where you should draw a lot of pictures and ask yourself, what abilities do these different guys need to have? All right, so when we're adding a monster to an exit, we will go ahead and ask our destination room, that is the place that this exit leads to add a monster. All right, so now we need to go and update room to have an add monster function. But before we do that, I want to go ahead and give my commentary right here. Because right here, this is when I know the direction I was just heading. If Mr. Gonzalez went to the north, this is my opportunity. This is the guy that knows about that direction, north. This is my opportunity to ask some questions where it's like, well, if he said north, that means I can say he arrives from the south. He said west, he arrives from the east. Make sense? This is the point in time where I have that information. If I wait until the room level after I've called add monster to my destination room, at that point in time, I no longer know the direction I came from. I've just popped out the other side of an exit, and now I'm here and I'm being added to the room. If I wanted to do it at the room level, I would just have to add add another parameter to add monster. I can say, I want to add the monster to this room. Here's the direction I was coming from. Make sense? All right. So we'll go ahead and add the monster. I'm going to go ahead and throw a little error in there for a moment to remind us to come back. Hey, I promise you this code doesn't run right now. All right. Another good trick because you're letting this thing run organically. Since I want to make sure I come back here, I'll let the compiler scream at me. He'll let me know there is something funky going on. Line 15 of exit. Take a peek. All right. Put a little comment. Say the opposite direction. LOL.
What? Wow.
Our future's been set at this point. All right. So,
Wow.
hey, it's not the worst misspelling I've had. All right. So let's go to add monster. Oh, actually, what am I doing? I'm calling add monster to destination room. Exit, take exit. Where's my add player? There's add monster, current monsters, current number of monsters. Okay, I already have it, right? We wrote it when we added our monsters initially to these rooms. All right, good. Which actually is probably a good reason why we actually would want to do that commentary inside of exit rather than here, because we probably don't want it to spit out to the screen. Mr. Gonzalez arrives from nowhere when we first put him into the room, right? Well, maybe you do want that. Let's go back to exit here. All right. So now what we want to do is we know the direction that we just came from. That's going to be this dot direction. Whoever took this exit took it in a specific direction, and that's the direction this guy is coming from. So the direction for this guy would be north for Mr. Gonzalez's example. All right. So we need to find what's the inverse of north. We can just write a whole bunch of if statements and things like that, right? Or we could do something like change the who?
Or like add.
Yeah, you could. Yeah, I mean, there's nothing wrong with that. I mean, you can certainly do that. What I'm going to go ahead and do is I'm going to say we're going to have a string array. And we're going to call this guy, you want to call it map? You like map?
That's what you
All right, so we'll call this guy map. And we're going to put in here north, south, east, west. Call this guy inverse map. And this will be south, north, west, east. So now I just have to go through map, find the direction I just took. And then once I know what bucket that's in, 0, 1, 2, or 3, spit out the same bucket for inverse map. Right? So for int I is equal to 0, I is less than map dot length, I plus plus, if map at bucket I dot equals, and I guess we can say equals ignore case, but it's assuming we call this the way we're already calling it, it won't be a problem. This dot direction, then we're going to go ahead and say system dot out dot println m dot get name. So a monster can get its own name from the inhabitant class, right? Get name. Concatenated with arrives from the concatenated with inverse map at bucket I. All right, so Mr. Gonzalez arrives from the, if I found that he took the exit north at bucket 0, I'll say he arrives from the south, which is bucket 0 of inverse map. Go ahead.
What's the difference between whenever you're comparing to string, whenever you use equals and compare?
Well, compare to is you can use compare to for equivalence to check to see if a compare to returns an equals 0. But compare to typically is used for deciding which word comes first, what's called lexicographically. It doesn't pay attention to capitalization. But if you're trying to alphabetize strings, you can ask, does this string, when compared to another string, if it's less than 0, the calling string should come before the string you checked it against. If it's greater than 0, the calling string should come after the string you compared it to. If it's equal to 0, they're the same string. So you could use compare to equal 0, or you could just say equals. Yeah. All right. So this is a way you could have pulled off the inverse thingamajiggy. You could have also just asked a zillion questions. If it's north, spit out south. If it's east, spit out west. So on and so forth. All right. Not the end of the world. Effectively, we're doing the same thing here. But after we do that commentary, we do want to break out of that loop. Technically, we could just return because we're done here. But at the very least, we'll break out of this for loop just in case we wanted to throw something else in there and let the add monster function die a normal death. All right. So when we add a monster to an exit, we're going to go ahead and add the monster to the destination room. Then, so that's already happened. Technically, the monster will be added to the destination room ahead of our commentary. But then we'll go ahead and spit out to the user. And since everything is happening at our current screen here, not at people connecting over the internet to our server, which isn't all that much harder. But then we'd have to make sure that we spit out that commentary of Mr. Gonzalez arrives from the south to all of the connected users over each of their individual sockets. So at that point in time, we would probably have a collection of network sockets in the dungeon at the dungeon level and spin through that whole thing and just spit that string out to all 30 characters that are connected over the internet by IP address. Something like that. Network programming stuff, but it's not really hard. We just have to think about it, right? Where in this case, every single user, which is one, is staring at this monitor. So anything we write to the screen, they'll see. All right. So this will print out our inverse thing. We break out of the loop. That's add monster. All right. So now he's actually made that move. We could tell the after that happens, we could reload the room for the player. We could ask the room that the monster was in. No, we don't want it to redisplay itself, because then the all those other rooms that aren't in the room we're currently in, we're in the room with Mr. Gonzalez initially. Well, if Dr. Locklear does some movement over here, we don't all of a sudden want the room he was in to spit out an update like, hey, obvious exits to the west. Yet we're still in that first room where there's only an obvious exit to the north. All right. So we have to decide, how do we want our current room to pop back up? Do we have a dungeon has a group of, do we have players? The starting room, add player. Well, we'll just let it roll. We don't need to spend a bunch of time on this. If we stored all the players that ever enter our dungeon into an array here, we could do something where we spin through a loop and tell each individual player's current room to display itself. And presumably those players are connected from different places, so they would only see the room they're currently in. But we only want to go so far with this this thing. As of right now, if do we have a look function? Let's just put that in real quick. We have a quit. Okay, so let me just do it real quick and I'll take your if line dot equals ignore case look. Then we'll say this dot get current room dot display. So we added another function called look. So if we type in look, it'll tell the room that we're currently in to display itself. Okay. We are going to have a little bit of weirdness going on right now because of like Dr. Locklear moves to the west, somewhere else on the map. We're going to see at our screen, so-and-so arrives from the east, yet he didn't actually arrive in the room you're in from the east. So we probably should put some logic in that make sure that we only say something if we are going to the room that the player's currently in. At that point, we then need to make sure we're keeping track of the players as they were added to the map. What does the room currently know about? Yeah, if the current room, current number of players is well, yeah, if it's greater than 0, that's when we'll announce we're leaving. If it's if the destination room's current number of players is greater than 0, that's when we'll announce that we're. So what we can do is inside of room, when we take a exit for a monster, where do I actually say my? Right, but where am I saying my so-and-so leaves this room?
You haven't said it, so.
Oh, I've only done arrives at this point. Okay. So inside of here, what's this? In worker B. Thank you. Yeah. Yeah. So inside here, we really only want to say this if the monster that's moving is in the room that we're currently sitting in. So worker B, he knows about the room he's currently in, right? So we can say monster get current room has exit. I'm also going to say, and this dot the monster get current room. Do we have the ability to get the number of players in a room? No. public int get number of players, so we can ask a room for the number of players that are in the room. For some reason, in this case, we're going to say if the current room dot get number of players is greater than 0, then we're going to do some announcing. We know there's only one player in our dungeon right now. So effectively, if the room that Mr. Gonzalez, so the room that this monster is currently leaving, has a player in it, we're going to say something. If it doesn't, it's going to keep it quiet. We'll do our movement, but we're not going to actually say anything. Similarly, inside of exit here, we only actually want to do really any of this stuff, checking the alternative stuff, if the place we're going has any players in it. So if this dot destination room get, what I call it, get number of players is greater than 0. What, this stuff? No, just highlight it and hit tab. Otherwise, I think you can also highlight and hit beautify, but it'll do stuff. Asking you shall receive. All right, so when we add the monster to the destination room, we're always going to actually put them there, but then only if there are some players in that destination room are we going to do that reverse mapping, announcing something or other thingy. That way we're only actually seeing some commentary that impacts us directly. If we're not in the room that the monster's leaving from, we don't want to hear about it. If we're not in the room that the monster's arriving to, we don't want to hear about it. Make sense? All right, so this stat cannot find get number of players. It's because I didn't call the function version of that. I know. It's called number of players. Oh, current number of players. That's what it's called. Current number of players is my int. All right, so we'll chill here for a second until Mr. Gonzalez takes off. Leaves to the north. So now if we type in look, didn't he leave the room? How many times can he leave to the north? He hasn't left the room. But why? All right, so we tell him go follow the worker bee, because this is where it gets directed from. We do say Mr. Gonzalez leaves to the north. Oh, we actually never tell him to take the exit. We did all the setup, but never actually told him to get lost. All right, so we'll do some announcing, and then we're gonna say this dot the monster dot because it's we're gonna do it regardless, even if he's not so really we can do it 2 different if statements. Because we want to have him move if it already has that exit. We know we've only called this if it has that exit. So here, let's just make that assumption to keep this quick. We're only in this function if we oh wait, no, this is where we're asking has exit. If it has this exit, then we're going to do one thing. All right, so if it has this exit, then we want to actually remove him from this room. All right, And removing him from this room will be to take the exit, right? As exit, take exit, passing it the monster. And the direction. We already have the direction. So we'll say this dot the monster dot get current room dot take exit, passing it this dot the monster, that's the who, that's the one taking the exit, and passing it direction, that's the direction they're going. All right, and we do this if the place we're trying to go has a direction. Then we'll add a second if statement here. If the place that we're going, or the place that we're coming from, has more than 0 people in it, we're going to make some announcement about us leaving. Right? So if it has an exit, go ahead and leave, and then situationally make an announcement. Situationally make an announcement about leaving, only if there were players there. All right, so now I think our guy should have actually have left. So we'll wait for him to get lost. All right, Mr. Gonzalez leaves.
He arrived first, or how do you arrive first?
Oh, because we added, actually, why would it say he arrived?
Because it calls arrived. Wait, no. Wait. Do or flip them. Look, let's do.
Okay, he's definitely not here anymore. But why did he? It makes sense that he would have said he arrives from the south in the next room, but we're not in the next room. So the current number of players. So this guy says, if the current room, oh, the monster's already left.
Oh.
So we'll make our announcement prior to actually leaving, because we're asking some questions about the room the monster's in after he's already gone to his new room. All right. So hopefully it just says he leaves to the north. You get nothing else because we are not up there. We're not where he just went. If I say, look, we notice that he's gone. Oh, Dr. Wallace. Oh, he did a turbo pop in. All right. Oh, Mr. Gonzalez and Dr. Waller here. Now it's just Mr. Gonzalez. And Dr. Wall is kind of sneaky. He just zips in, pops out. All right, let's just call this good enough. All right, so questions about let's call this our final state of our Java version of our dungeon. Okay, we have a decent understanding of threads and kind of what the purpose is, that kind of stuff. All right, so let me save this and grab the code. Final dungeon Java code from 2/27/23. All right, so now let's start talking about Unity. All right, I think it's Unity 3D. All right, so if you go to unity.com, so www.unity.com, you probably want to go ahead and just click on Get Started. All right, they're going to try to sell you on some of these higher ones. You want to go to the individual. Now, you can go to the student one, if you want. You have to like, I think sign up with your cuw.edu, and I think it instantly gives you permission or whatever. But for what we're doing in here, you can just use the free one too, the personal. We're not doing any sort of like their paid tool has like collaboration stuff turned in, and it gives you the ability to like remove the watermark when you first launch the your game, so it doesn't say powered by Unity. Instead it says, you know, built by, you know, whatever your company's name is, that kind of stuff. So for us, it doesn't matter. All right, but you're going to want to get started with one of those. And now it's going to say download, and you can choose what you're going to download for. So for many of you, it'll be the Windows version. If you need it for a different platform, let's go. You can download for Mac or for, there is a Linux one, but I think you probably have to run it through Winex. So if you're running Linux, natively on Linux, okay. But in any case, if you're doing Linux, you probably know what you're doing. So download Windows or Mac. I think for Mac, you have two different options. Let's see what this guy ends up looking like. I think I already have it on this machine, but let's just look what I'm sure the Windows one is a executable. You just double click on it. It takes you through, just click next a bunch of times. All right. One thing you will want to do as part of the install, at one of the screens, it'll have like a choice for you to choose some stuff. You do want it to install Visual Studio. Okay, Visual Studio is the code editor. It's the thing we're going to use instead of online GDB. All right. And I'm going to show you another place. So even if you forgot to do the Visual Studio thing, I think you can do it after the fact as well. But during the install, if it asks you whether you want Visual Studio, you do. And then you also, at the very least for you, want the either the Windows or the Mac tools so that you can create executables that run on your computer. Okay. Realistically, it doesn't actually matter because we're going to probably be testing just by hitting the play button, which just runs in the current runtime. But those are some of the things. All right. So ultimately, after you get this guy installed, initially what you're installing is this thing called Unity Hub. And Unity Hub is your starting point for various versions of the Unity editor. So when you come into Unity Hub here, there's a thing called installs. Notice that I only have 2021.3.19F1 installed. I think that is the latest supported version. There is a newer version of it. So if I go to official releases, let's say, is it going to show me what the official releases are? Or that is the official releases? Maybe I had to click on install editor. Yeah. So if you come up here, I already have, this is showing me the editors I have installed. I have this editor installed. If you go to install editor, it looks like you can look at the official releases here. You can also look at pre-releases. These are like the newer betas. Just so we're all on the same page here, go ahead and install this one right here, 2021.3.19F1. This is the latest stable version that they fully support, whatever. There might be a couple of bells and whistles that are missing, but I promise you when we have our high definition 4K boxes moving from room to room, you are not going to need some of those special features. All right. If you want to mess around with one of the newer betas, that's fine. But anything we do in class, if you just want to make sure an even keel, will work using this version right here. So for Wednesday, go ahead and get Unity downloaded, installed on your computer, get this version going, and then we're going to start using Unity on Wednesday and start with just kind of dropping some things in there and understanding how the editor works and how do we make our fields work, that kind of stuff. Questions, comments, concerns, bribes? I think it's called VS Community, what you install. So some of you might have something called VS Code on your computer. That's a just kind of a glorified text editor. And you can use that for this. Visual Studio Community is the one you want, the normal Visual Studio IDE, and it comes free with Unity. They have a partnership, so just make sure you hit the check boxes for that. It's somewhere. It is somewhere in there. If I go into, I think I should show it to you right here. If I go into settings, I go to add modules. Somewhere in here, here's the iOS support. Under Dev Tools. Oh, Dev Tools right here. Make sure you choose Visual Studio over here. I already have it installed for the Mac. There's a Windows version of Visual Studio. That's where it started actually, but make sure you have your Dev Tools turned on. You can do that after the fact by just hitting the little gear right here. All right. I will see everybody on Wednesday.